Hey guys, today we're going to be solving this AP Chem problem. Okay. So the question 79, 78, I was assigned 79, but I'm going to be doing 78 as well because it helps answer my question. Okay, so starting with 78, it says use the following standard enthalpy of formation to estimate the NH bond in ammonia, and then it gives you all these standard enthalpies of formation. So the first thing I do to solve 78 here is I kind of get an idea of what I'm looking at. So in ammonia, so that's my NH3, and we're in the chapter where we're associating with bond energy, so I know that it's going to disassociate into nitrogen gas and hydrogen gas. But I need to make sure the hydrogen gas is balanced, so there's three, I hate this chair, there's 3 hydrogen gases. And they're telling me that the standard enthalpy of formation for nitrogen is this, and for hydrogen is this, and for NH3 is this. So I have to calculate what I think the bond energy for the NH and ammonia is and compare it to the one in table 8.4. Okay, so we know the formula, like the summation, and then it's like bonds formed, bonds broken, you know that one. Okay, so I'm going to take my 400, I'm going to take my delta H is equal to 472.7. That plus 3 times 216, because 3 hydrogens and 1 is 216, subtracted by my value for my NH3, which is 46.1, and this, why was that so large? 46.1, and this will give me a total of 1166.8 kilojoules. So this is your part 1 of 78. Then in order to find the value of the NH bonds, you have to consider how many NH bonds there are. There's 3. You can also think of it like, here's my N, H, 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 you have 2 electrons here, H, H, H. There's 3, right? 1, 2, 3. So I take the total 1166.8 and divide that by 3 moles of like my NH bonds, which is going to give me 389 kilojoules per mole, which is of NH. So this is 78. And then when we read this, like this last part, compare this value with the value in the table 8.4. The value in the table 8.4 says that the value is 391, and this is a very obviously close rough estimate, so we can move on. Okay. So 79 asks, I meant to do that one. 79 asks, the standard enthalpy of formation for N2H4 is 95.4 kilojoules per mole. I'm going to highlight that. It's going to be useful for N2H4. Use this in the data on exercise 78 to estimate the NN single bond. So they're telling you the NN single bond of N2H4. So first thing I would do is draw out what N2H4 looks like. So here's my nitrogen. Here's my other nitrogen. And then I have a hydrogen right here from my H and another hydrogen. I have a hydrogen here and another hydrogen here. This is 79. Okay, so here's my N2H4. Oh, my hydrogen was so ugly. H. Okay, so in this N2H4, we're trying to estimate the value of the single bond between these 2 nitrogens right here, this pair of electrons they share. So in order to do that, I'm going to have to use that summation formula. Something, I forgot exactly what it looks like, but I just know kind of how to do it, and it's like delta H and D, something like that, right? We just know the concept, that's all that matters. Okay, so this is going to yield we can tell 2 nitrogens because 1, 2, 2 nitrogen plus 1, 2, 3, 4 hydrogens. In order to find the delta H just for like this part, just like this part, I'm going to show you guys. So just the standard, and this is the enthalpy in general for the N single bond plus the 4D of NH, okay, is going to equal, so we're just talking about this thing as a molecule because we're trying to find the total. So we need to find this piece and this, we need to find this piece and this piece in order to solve for this piece, right? Okay, so we can calculate the enthalpy by going delta H is equal to the 4D of NH plus the 4 times this 389, because this is the value for an NH bond, 389, okay? And this is this right here is important because now when you're solving for the whole thing, you're going to plug in this for the part of the formula that you're solving for. I'll show you what I mean. So now they're telling you to estimate the NN single bond value, right? So you're solving for this. So when I'm doing my standard enthalpy, sorry, I don't know why I keep saying standard enthalpy, I can't stop, but now when I am solving for my standard enthalpy of formation for this whole thing, it's going to equal to 2 times the standard enthalpy of formation for my nitrogen, because there's 2 nitrogens, that plus 4 times the standard enthalpy of formation for my hydrogens, minus the standard enthalpy of formation for my N2H4, which is going to convert down here to delta H is equal to 2 times 472.7 plus 4 times 216. This is all technically in kilojoules, minus 95.4, which is given with this formula, this equation, 95.4, which is going to give you a standard enthalpy of formation to equate to 1,714 kilojoules. And then remember we found this with this, right? So we have this formula, right? We have this big formula. It's very important, and I'll tell you why. Because you're solving for the NN bonds, but now you have the total formation. So you can use that to solve for your NN bonds. So you would go, you have your total, which is 1714 equals D of NN, plus that 4 times 388.9, multiply out, subtract, you get your D of NN to equal 158.4 kilojoules per moles. And when you compare this to table 4 has a value of 160. So you can see that this is a correct sort of method. Thanks, guys. Also, let me elaborate. The reason that you are finding the enthalpy formation for N2H4 and then plugging it in is because the enthalpy of formation for N2H4 is important when you're studying the single bond of the ends in the N2H4, right? But you can't just solve for that without having the total, because the total is what will help you. You're basically doing algebra if you think about it, right?